Thank you, Wayne. Yeah, I'll do the presentation now. If you have questions, let's get some questions until the end, and then we'll, raise hand and you can ask some of the questions. Just write it down so you don't forget or something, and we'll get it after. The title of this talk is how to start loving writing tests again. And you might question, why is it structured in the way? Why is it writing again? Why start loving again? Um, Very early on, I think, is when, as a software engineer, we join the field. We're excited about getting things right. We do things right. We're trying to write the test, of course, because everybody tells they're awesome and they're needed. Even you write them, and then, as time goes by, um, you get different habits. You need to rush the project in because it needs to be delivered and things like that. You might say, oh, maybe testing, I'll do some of it later. Or if you're working as a contractor, well, my client's not really paying me for testing, I'll kind of skip all this. So, or you're running into ways where it's very hard to write tests as well. And you're like, well, it's so much time and so much problem to write them. I just don't have any time for that. So you basically frequently people get a little bit of dislike towards writing a test. So this talk will show you how to get back that love and also to see the value in them if you don't see them, the value in that yet. But I'm going to start with a brief story. Uh, Actually, I'm going to start with introducing myself, although Wayne already did it. I'm currently a principal UI architect at Cisco. Um, Very happy with the team here, working with talented folks in our front end team here. I'm part of the Nginx core team, so I've been very active in Nginx world for some time, including doing a bunch of talks, workshops, different conferences, and things like that. The closest one would be probably in NGDE. This is Angular Denmark in Germany conference. So I'll have a talk and workshop there as well. So if you're there, say hi, come say hi. I organize Angular Toronto, although we've been a little bit on pause for some time, waiting to get in person to restart some of that. And also part of the Angular Google Developer Expert group. So that's about me. But again, now let's get to the exciting part. Some kind of story. Imagine a world where multiple very popular apps broken down all at the same time. Users start to panic, switching to other apps, and other apps start collapsing as well because they are not, expecting so much load on them. It basically starts a complete chaos. The outage causes the company about $164,000 a minute in revenue. $164,000 a minute in revenue, and it's been going almost for a whole day. The stock decline wipes away more than $50 billion in the market cap and costs the CEO of the company roughly $6 billion just in that day, just because of all of that. And why is it happening? Well, you guessed it. It's a tiny little bug. It's a tiny little bug in some configuration, but it took down most of the Facebook and Facebook related apps back in August of last year. So you'd say, is it worth testing? Well, I think they would say probably worth testing. It costs so much when we're not doing it, when we're skipping some of those things. And I'm sure Facebook has a very good testing culture in general, but things sometimes still happen. So there's no, extra tests are always useful as well. So with this, let's go over the agenda for this talk. And I'm going to touch on a few things. First of all, I'm going to touch why we actually need to test. Well, you saw one example, but I'm going to go over more examples. Why do we need tests? Then we'll talk about something called ciphers. Then we'll show how we can test services in a better way. And then finally, we'll touch on testing components. So testing. Why do we need testing? Why do we need testing? Well, we need it for a few reasons. And you might know some of them. You might not know the other one. Again, this one is to give the complete picture of why we do this. First, we want to validate the behavior. I mean, we're testing a thing. We want to make sure that it works the way we say it works, so we hope it works. So first thing is to validate the behavior of tests. Now here we'll see a lot of, I'll get back to it as well a little bit later, but we're not testing that some property set. We're testing that a thing behaves a certain way. We don't test internal things, we test how it behaves externally. So that's an important thing, and we'll get back to this. So behaviors. The second thing is documentation. Our tests serve as the documentation of our component. Ideally, a person without less familiarity with this component or class or some piece of code should be able to go test and read exactly what kind of things this component is supposed to do just by reading the tests. So documentation is another purpose why we have testing. The next one is confidence. Testing brings us confidence that, first of all, we validated that it does the way we hoped it would, that's one. Secondly, it would be confidence during refactoring. If you're moving certain things and you're not changing the behavior of the class or of the component or of whatever, then it stays the same, so it shouldn't be broken, right? And if you touch something that changes the behavior, you'll have a test that's will break and say, hey, you did something that wasn't expected. So it brings confidence. And the other one, confidence, typically we work with the teams, usually 5 or more people that could actually be working on the same piece of code. We don't always have the full context of every single behavior of a certain component, for example. This gives us confidence that when you touch something, you didn't break some other behavior of this component. Again, this is all about the confidence as well. And lastly, why we write tests and why the tests are necessary. And this is a very tricky one, very overlooked. It actually validates the design of our thing, be it component, be it service, be it the whole, end-to-end flow, whatever. It validates the design of it. If you find yourself that it's really, really hard to write the unit test for something, it might mean that your thing that you're trying to test is actually not designed correctly. And for those of you who ever tried to unit test 1,000+ line component that has a gazillion of injected services into this, you can probably relate to this, right? It's so hard to write a unit test for that thing and that's just the unit test itself screams that, hey, something's wrong. The design of the component is way overblown. So that's why we do the testing. Behavior, documentation, confidence, and design of our system. Those are whys. The next thing is, okay, we got the why. How do we write it? How do we write a unit test properly? A unit test would have a certain characteristics of a good unit test. The first one is, well, it's just very obvious. The test has to be correct. The behavior the test does is, should be the one that we expect from it as well, right? So it's working as it's expected. So this is the most simple characteristic, right? The unit test should be correct. If you're validating something incorrect, or you're not validating much and just have a test for some line coverage, obviously it's not doing that. So the test should be correct. But what's another very important thing from the correctness is actually clarity. The component should be the test itself should be very clear as well. Again, I was talking about the documentation, and clear is also kind of characteristic of that, to be able to use it as documentation, meaning that developers should be able to understand, what everything that this component does, for example, but just reading the names of each of test in T suite. That's one. And secondly, developers should be able to use this class, right, or component, by just examining the test code as well. So that's another one. So clarity is very important. But how can we achieve clarity? We can achieve clarity by the next characteristic of unit test, which is concise, being very small, packaged, and completeness. And those two frequently are very much at odds to each other. So balancing is very important. So what does concise mean? Concise means the test itself should not have a lot of distracting information in the test itself for somebody who's trying to read the test and understand what this test does. If you've seen a lot of setup of some mock data in the test itself, within the test itself, it's sometimes not clear what exactly you're trying to validate there. So maybe there's a way to remove that out of this unit test, right, and have the setup somewhere. So the test should be concise, smaller, but at the same time, it should be complete. And that means that all the relevant information the user needs to understand the test has to be there without tracking down through many, many different components, different mock files or whatever. So for example, if I need 3 large objects, I shouldn't be putting all those large nested objects in the test itself. I should have maybe a function that says generate, and you just pass the number of 3 of those test objects, because you'll be validating that, hey, this component actually displays something 3 times, whatever. So complete, all the information necessary within the test. Concise, it's small, right? It should be readable and understandable when you go through this. And again, this is almost like the craft of writing good unit tests, which would take a lot of practice as well. So that's the third characteristic. And again, I can't stress enough how important the conciseness and completeness is. All right, and the final one is resilient. Resilient means that a test shouldn't break if some internal implementation changes without the change in the behavior. So behavior of the component stays the same. So if you, for example, refactoring or adding new things that are unrelated to whatever you were testing before, tests should not break easily. The opposite of resilience is, of course, brittle, right? So we don't want to have them brittle and be broken on any specific change. And we'll see how we can keep the resilience high of the tests as well. So those are, why do we need a test, and what are the characteristics of a good test? And this doesn't apply only to unit tests. It actually applies to all kinds of tests that there are. There are end-to-end tests, integration tests, unit tests. Unit tests, you might say it's simple, and I think most people understand what that means, but we'll touch on that more in a second when we talk about testing components, what actually a unit test is. But it's typically the smallest piece of functionality that we test. We typically test that component or service with the unit test. We test it as a unit. It means that we mock everything outside of that component, and we work with the component specifically for some of its inputs, outputs. So we test the unit in isolation. Integration is where we test multiple units. Sometimes what integration and end-to-end tests are, people have a different understanding. And I'm not going to be arguing what's the right way. For me, integration test is, for example, in the web application world, integration test is where we mock all the server dependencies. So we're not talking to any of the backends, but we build app as a whole. We serve app as a whole. App itself thinks that it talks to the actual backends, but what we do, we actually mock backend responses. We catch requests, analyze requests to have specific data. So this is the integration test. Those type of tests in the web app, sometimes known as end-to-end tests, like you share ciphers end-to-end tests, but those are, for me, those are integration tests. All right, so you test the whole app in isolation, but the whole app itself works as a single unit. And then there's end-to-end tests. Those tests are actually running on specific environment, meaning all the systems are involved. They're still all not mock. They're all running. And again, this is a testing pyramid here. Those should be like a handful of tests at most in your organization. I know we typically have what's called like the hourglass shape testing, which is very heavy end-to-end, no integration tests, and a lot of unit tests as well. We do need to try to shift to the pyramid, basically having a very small number of end-to-end, a solid number of integration tests, because those could be running during your PR mergers, during your, when somebody wants to merge a PR integration, you can run there, you can run unit tests, you can catch all those things, and you can actually block on the results of those. If your tests fail at that stage, you can decline the PR to be submitted. So the unit test, integration test is a very important, critical part during your PR mergers, for example. And end-to-end, again, very thin layer on top, just validating things before you basically push to maybe production, or even running them in production as your detection mechanism of something going wrong. All right, so those are the type of unit tests. Now you know the whys, the hows, the what type of tests. So you now could be pretty much almost as a Faith here, who won the 2012 gold medal World Championship yesterday, the day before yesterday. Fantastic results. I know a lot of people from Kenya were actually watching her performance and were rooting for her, and it's a big deal. So let's now become almost a champion as she is. Okay, so we're going to talk about ciphers now. And you might be scratching your head, what exactly is ciphers? What are you talking about? Well, ciphers is abbreviation, and it stands for simple injectable functions explicitly returning state. And this might confuse you even more what exactly that means. Well, let's break it up apart. So it's a simple function which you can put some original initial data into. But that function is your setup function that would return you the state of your application, of your setup explicitly to you. Again, you still might be confused. Let's take a look at the example. I'll go over the typical unit test, how it's typically structured. You would have, you'd have a describe block, and then you'd have a bunch of things you're setting up, component fixtures, whatever, some of the services, mocks, and things like that. Well, typically it's a lot more there, right? There's a lot more, but let's keep it clean. It's there. Then you have, like, let's have an example based on a specific service, for example. So say there's a split IO service. Split IO is, for us, we use it for the feature flagging. And it's basically a runtime configuration of feature flags. It returns you if your flag is true or false, basically. Very simple, right? It's obviously more powerful, but we'll just use a very simple example. Let's see how the service and mock is declared and used in this typical test. So we'll declare the property somewhere in the describe block. Then we have our configure test suite function, right? That would do something. We'll set up the test bed. We'll use providers. And then there we would use a mock for it. For example, we want to say that split enabled or false, for example. So we are setting the service there. Then we have a before each block where we get that service back. And now it's that property that we had before has actually value. And then in the test itself, we would set the spy for it and return something different. Now we have 4 different places that are completely disconnected and all are dealing with how we mock the service. It's quite problematic, very error prone, hard to follow. And again, remember the good characteristics of tests. It should be clear as well, right? It should be clear. There's nothing clear about this, right? It's all over the place. So there's an alternative approach how we can set it up, how we can set up the mock for example, this specific service, and actually set up the whole environment for the unit test itself. But let's just look at this one, for example. So this is the alternative one. This is the ciphers on your left side now. Instead of having configure test suite and all this before each stuff, let's just have a setup function. And it's a synchronous function, right? So this function, and then we have a value that we can pass into this function. So that's why it's like an injectable function. So we'll set the value. By default, the value is false, but we can pass and set up this as a true as well. And that's the flag value that we want to set up. So this is a function there. Inside, we create a mock of it, which will be like a partial of the service, for example. Then we have a test that configuration where we'll provide that mock, right? We'll use the value. It's very clear where it's set up. And then the key part here is we'll return the split IO service outside from that setup function. So this is the ciphers. This function is what ciphers are called. Those are simple injectable functions explicitly returning state. And we're now returning the state very much explicitly. We have that return statement explicitly returning. How will we consume this? We no longer in the test just hope it's some property that is set. Instead, we would await the setup. For example, we won't pass any value to this because default it will be false. And we will pull it out, the split IO service out of it. So it's not just automatically appears on our test, but instead we're pulling it out from our setup. And because we can run the setup for every function, we basically are guaranteed that we don't have any mocks that we need to clear that were set up that weren't cleared, and basically, can guarantee that the order of tests won't matter here because every test would set up things from scratch for their own needs. So that's basically what the ciphers is. And again, it's very clear. It's not for disconnected places. It's a single place where we declare it, initialize the property, then we'll provide it in our test bed, and then we'll return it outside of the component, outside of the setup function, and use it in our test. All right. There's a whole article about ciphers, and first I've heard of it when I was part of the Firebase team. My teammate Moshe came up with it and has a very wonderful article about this. I can share the link later on, but you can probably do the search of testing with ciphers, and this is probably the one that would come up. So thank you, Moshe, here. All right, so that was ciphers, and this is how we set up the test in general. Now, how would we test services? And I'm going to show you a few things. Again, some could be controversial, some could be hopefully less so. But in Angular, we use something called dependency injection. And dependency injection is, again, a version of control. That means you don't instantiate something within your class, component, whatever. Again, this is a term that goes way outside Angular and was created way before Angular, dependency injection. But the idea is that you can substitute values with anything else in different places, including testing. So including testing is an important part because we want to substitute those implementations with mocks, right? So what Angular underneath does, right, anyway, right, when it sees the class and the C constructor and C injectable and it sees those things, it basically news or instantiates that class and puts the dependencies in it. If those dependencies are not instantiated, they will instantiate that in its turn, and so forth, right? But basically, that's how it works. I'm sure many of you already knew this stuff. So we can use this for our testing as well, for testing purposes as well. We can instantiate the class and provide the mocked services into this, mock dependencies into this. And in fact, I'd argue that with Angular testing services, you don't need template, you don't need to generate anything. You really don't need a test bed. You can just create a class, like here, like some new class, and you can provide the mocks into it just as they are in the constructor. This is the basic principles of dependency injection and testing with the dependency injection. So that would be, hopefully that's, it could be controversial because some people are like, oh, why the number of arguments, the order of the arguments now matter for me. And if I do the test bed, it doesn't matter. I think it's a very big argument. It doesn't really matter. If you change the order of arguments, you'll change it in the test itself. Why would you be changing the order of the arguments by itself? I don't know. But generally should be quite, good approach. Now, I've shown here how you can do the jest functions and create partial services over things that you care about. That's good, but you can also have a useful libraries that help you with testing. And in fact, I kind of like the library that what is it? Quickly forgot. I wanted to say his name, forgot his name. Guy from Hi-Res.io provides a jest autospice. Jest autospice, and the same thing there's for Jasmine if you're using Jasmine. And this allows you to create those mock services just by creating them from classes. As you see the special helper functions called create spy from class, and you can provide the service. It'll look in the service, it'll find all the methods of the service. It will basically substitute those methods right away with the jest functions, or if it's Jasmine spies, and basically would imitate that so you can validate things immediately. So you don't have to manually create it. It's basically automatically created for you. And then you can just use them in the service. And then, for example, in the test itself, you can validate, because these are not just methods, they are also spies. You can validate them already without any extra additional configuration, right? That, for example, this one had been called with some value. So I highly recommend this this library. It's really good. Now it automatically creates the mocks for functions, but sometimes you have some reactive properties that you want to spy on as well. For example, if you're using Nginx component store, or even if you have something that's behavior subject within your services that you want to just make, you want to put the spy on. There's a helper, for example, here's reactive property, right? It's some kind of observable, it's public, it's accessible from the component. You can do this by providing, saying, observable prop to spy on, and what it would do, it will automatically wrap it with the replace object, so you can just do things like next with, and it will emit the next value into your observable of your mock. Really helpful as well. So that's the jest out of spies. Okay, highly recommend it. The next thing I wanted to touch on is the global objects and maybe third-party classes. How will you test, say, your services if you have those? The suggestion is, for example, here I see this client, and then this is just some object that's on the window, right? It's available, or it's maybe injected through some third-party library. I would recommend not to initialize them, not to new them within the service, but instead wrap them with the injection token. For example, in this case, I'm wrapping them with the injection token. I say, hey, this is of this type, and I have a factory that would just return that object, for example. It could be global one too. But then in the test now, I can mock it as well. And if I don't mock it, right, if I was just newing it before, setting value becomes tricky. That value could persist across different tests, and we're trying to avoid that as much as possible. Remember one of the things I was saying, that our tests validate the design. And again, if we are writing the code just like that, it's kind of very simple to miss this design flaw that we have. So again, we'll create an injection token and we'll inject that specific token in our class. All right, that's testing services. As you can see, we don't really even need the test bed for it at all. Testing components. Testing components, again, is a little bit more involved. But I want you to take a look at this test. And you can actually unmute and say, hey, is there any issue that you see with this test? I mean, it's already using Cipher, right? Set up and create return component. Is there any issues with this test, or is it a good test? You can unmute and say, that's fine.
It's a bad test.
Bad test. Why is it a bad test?
Well, there are a couple of reasons. I think the first one is we are testing internal details, like spying that an actual function has been called instead of actually checking to see what has changed in the UI. I would also say even the description itself, for me, would have been better.
Yeah.
So what happens when the submit feedback has been called? It should express exactly what I expect to see.
Yeah. Yeah. That's right. That's right. So let's again look line by line. We have a component. Okay, so that's we set up component. I don't know, with test bed or with whatever, and that's that function. It's concise, right? It's concise and clear. By the way, it's awesome. Now we have this component. We're telling jest to spy on this function, or actually method that this component has, called thumb click, and then we invoking this method on this component, and then we validating that it was in fact clicked. We just invoked it in the previous line. So this test makes no sense. It's just a waste of CPU resources, in fact. It validates what you just set up. And the other problem that it has, we are completely ignoring another part of the component, which is the template. So we are invoking things directly on the component class. And I would like to take you all back for a second. Why are we writing tests? We want to validate the behavior of the test. In this case, we want to validate the behavior of the component. Not a component class, but a component. So that means that we should be interacting with the component through its public APIs. We should treat the component, not just the component class, the component, as basically the mystery box, something we can have some public APIs into and out of. So what are the public APIs of the component?
Template.
Yeah, let's take, yes, good. Whoever said that, it's good. That's exactly our component. It's not just a component class. It's the template plus the component. You might argue, well, Alex, the component has a handle key down. That's a public property. So it's a public thing of the component. That means it's a public API. And I would argue, no, The only reason why the method is public or some properties are public, it's because they need to be accessible by the template. That's the only reason. In fact, I wish in Angular we can have all private by default, or even we need to say everything's private, but then annotate public for template. I think the unit tests will improve dramatically right there. Because those things, the value, the handle key down, all of those things are public only because they need to be accessed to the template. Our APIs of the component are different. What are the APIs here? The input, the output, and some interactions through the template, and whatever we inject into the component, so basically some services. So again, this is a component. We want to unit test the component, not just unit test the component class. So the public APIs of the component are inputs, outputs, injected services, which we mock, right? If we want to unit test the component, we mock those injected services because we'll be actually providing some inputs through those injected services and maybe reading some outputs if component is evoking them. And the generated template, that's the public surface of the component. When we test the behavior of the component, we do not want to test if the property is set or if the method was invoked. We want to see what's in the display on the template, and then when we interact with the template, what this component has produced. That's how we test the component. So again, let's get a little bit more concrete and see the actual example. So here's our template. It's some input, that key down and things like that. Then we have some values, some view model there, whatever that is. We'll ignore it for now. We'll have some inputs, some outputs, and some method that handles this key down. We have a test that says emits a value. We click the key down, handle key down value, and we validate that this key down has been called with some value. Is it a good test or no? I hear you all screaming no, but you're all muted, but that's fine. Yes, it's a no. It's no, it's not a good test because we're just basically validating what we said. We're interacting with the component directly. It makes no sense at all. Okay, how about this one? We again invoke handle key down value manually, and we expect the update spy. So update spy, outputs something when we handle the key down. Is it a good test?
No.
No, good. I see that not all of you muted, but I hear you all screaming. No, it's not a good test. And it's already a better test because you're validating the output. However, you're still interacting directly with the component handle key down method. And in fact, you can see here, right, there's an ngIf here. Maybe this input is not even visible, but we are just invoking it because that's what we do. Right. In fact, if a user tried to do this, this input is not visible, but we just validated the behavior. We're done here, all happy. No, it's not going to work this way. So let's take a look at another test. Another way to write this test. In this case, I'm using something called Angular testing library, or this is basically based on the test library. It's for React, Angular, and other things. And that actually emits some DOM interactions here. So in this case, I'm doing the user event and I'm clicking on the text box. So basically you'll find it somehow, the specific text box, whatever. Now I'm interacting with the template. I'm not interacting with the component instance. I'm interacting with the template. And template will invoke this method and it will produce the output to that, search component, something was updated. Now, this is a good test because we're completely ignoring all the internal implementation details of the component and we're interacting with it through its public APIs, the templates, the inputs, the outputs, and again, the services that are injected into this. All right, so that's how we interact with it through the public APIs for testing components. Now, setting up the component. very frequently, we just use the testbed configure testing module. Again, this is a very popular approach. However, I would recommend something else. I would recommend another library that actually helps you wrap this all up, makes it very easy to work with, and a very very well supported library is called Angular Testing Library, something that I mentioned before. And let me show you how you would set up it instead of testbed. You won't see testbed ever again. You won't need it at all. You forget that word, but it does all for you. And let me just show you how you can do it easily. In fact, this will also help you set your inputs and outputs for your component as well to easily interact with the component under test. So say I have some search component that is basically under test. I want to test this component. And again, here I would just use a template that uses this component. Basically, this is the component. And this component has a few content projections as well, like some of the options. In your case, they might not have anything. Again, most of the components have no content projection, which is fine. I just show you that you could, with this approach, you can even test what content projection does inside the component. Most of the time, you'll be just your component, some inputs, some outputs, and that's it. Here we see one output. Again, remember this is the update one. And we'll create a method for it. It's handle update. And in fact, our handle update is our update spy. So inside the await, this is a synchronous function, the render this component. Then I'll provide the properties, which is their inputs and outputs to handle update. For example, is your output that you would be watching with your spy, right? Again, hope you're following me there, because you do want to validate that the output was emitted, right? And then it would import the components module, and in this case, it imports some other modules because it requires it here for the content projection. But very frequently, you'll just import one module and maybe a few other ones, and I'll get to that in a second. This is how you would set it up. No test bed, a lot simpler. Again, update is your output that you'll be watching, and again, it's part of the component properties here, right? And then here's my update spy, by the way, right? It's just function. Now I would add the ciphers on top of it, right? I'll wrap it with the setup function, and this setup function will return to me, well, this result, just in case you need. Most of the time, you actually won't even need it. But the most important part would be update spy, because you would want to interact with it somehow and then catch the spy when it produces this output. Okay, so that's plus ciphers. How would you interact with this component? And this is where I'm going to talk about test harnesses. How would you be interacting with this component? Well, for me, what I see, I don't see the template of this component, right? For me, it's just a search component. I don't know what it does. I don't know how it's structured. In fact, it should be the internal implementation of that component. So I don't know how it's structured. I mean, I could try to interact with it through the DOM, which is the right thing to do. I can do like user events, and I can type, and I need to find some input in there, right? And I want to just do some search text into this. I can do that, but that kind of assumes I know how this component is structured inside. What we could do a little bit better is use test harnesses. Test harnesses, again, been out for a while. They're part of the Angular, I think, material SDK, CDKs. And it allows you to wrap your component and encapsulate all the implementation details of it inside a harness. So basically, you can interact with this with a harness. What does it buy you? What does it give you? Well, this is a very popular approach for components that are common components in your thing. Say your common inputs, your common checkboxes. You should know how it's implemented inside. Moreover, if you ever change the implementation of your search, for example, search field that's used in multiple places, now you have to go and adjust every single test to pick the correct way to input that data. Instead, you can wrap it with the component harness. And with that harness, you can just tell that what you want to do, and harness will do it for you. I don't know if you're familiar with the page objects for end-to-end tests. This is kind of similar approach to encapsulate the behaviors or the interaction with this component into a specific unit, which can then be reused in multiple places. And next time, the internal implementation of that component changes, you do not have to go and all over the code base adjust that usage. You can just adjust it in your harness, because harness is basically wraps the intent, what you're trying to do with this. So let's take a look at this one. I'll create this search harness, right, that knows how to work with this search component. And then I'll expose this harness as well. You see I have the test.dat harness loader environment, and then getting a harness back. Okay, I'm getting my harness. In my harness, I'll just send keys, right? I want to type this in my search, like this is a test, for example, right? And then in my search harness, I can also validate that, hey, get some input back. So this is how I can interact with the harness. And now all the other components who use the search can also interact with this harness as well. So this is basically Angular testing library plus ciphers plus this harness. That is the cleanest, in my opinion, the cleanest way to set up your tests. They're very easy to read. They stay resilient, right? Resilient because remember, if you change things, you shouldn't be changing a lot of places. Test harness help with the resilience. They stay concise. They can stay complete and clear as well. So you're basically hitting all of the characteristics of a good unit test. All right. So we talked about why we need to test. We talked about ciphers. We talked about how to test services, and we talked about how to test components. Now I have a few bonus sections for you. Some of the best practices that I've seen through testing. When you provide and test things, make sure you are actually providing things that are needed, especially if you're trying to mock the service. If you are not mocking the service, guess what? The actual implementation, Angular will inject your service, especially if it's provided in root, and the actual implementation will be injected. So I've seen this many times where some services are provided for no reason in your testing module or even Angular testing library in your render function, or the ones that are actually needed, the new ones, weren't mocked at all. It's a harder problem, but make sure that you do mock all their services, right? Because if you don't mock them, you guessed it, the actual implementation will be pulled into the test, and that might break tests in very interesting ways. That's one. The second best practice is, and again, there's no particular order. This is just a collection of some of those. Keep all it set up within describe blocks. Even if you're not using, if you don't plan to use ciphers, which I do recommend to use, still keep them within describe blocks. Anything outside of the describe block could be leaking to the other tests and can cause very interesting results. I heard it's a little bit better with Jest, but this was a very common problem with Jasmine. But anyhow, in any way, try and keep everything within the describe box so it doesn't leak across the tests. The other trick is nested describe blocks are fine. If you need to nest them and group the tests that way, do it. It's fine. Your test itself, the name for the test will be basically picked from all of your describe blocks plus the test itself. That's the name in the it part. So it will basically concatenate all of them and have a single test. So it's completely fine to have multiple nested describe blocks if you want to break it down by specific functionality, for example. So do not, shy away from this. The other one, it's very frequent and it's almost common for our unit tests to start with should. You should. I mean, that's fine if you use that standard. However, we're trying to promote that, hey, don't shoot it, just assert. Instead of it should be called when something, it says it calls this, or it is called when, it keeps the test name shorter, and it also asserts that this is the functionality, not that, well, it kind of should do this thing. So those are like a few reasons. Again, it's minor, but I feel like I feel it's a nice one to follow. Number 5 is fake async. So whenever you're dealing with time and you're trying to advance the time, if you're not mocking the time, guess what? Your test will be slower. If you have some debounds for 3 seconds, your unit test will be actually waiting for 3 seconds until your debounds happens. Do use the fake async whenever you deal with some of the time thing. And in fact, in our case, when you do the setup, which is a sync function, it's completely fine to have fake async with async. It would still work just fine. In fact, Angular components have a specific test to ensure that it works correctly, so they never break it from a framework perspective. So again, fake async for advancing the time. You can flush the thing they advance. You can tick by a specific amount of time. For example, if you have debounds of 3 seconds, you can tick by 299 and make sure that it's not happened yet. Then you can, those type of things. So that, use fake async. It's very powerful. The other one is, again, very general, and I've seen this a number of times as well. Ifs and for loops, avoid all those conditional logic inside your unit test. Do not try to automate the automate tests that create multiple loops that verifies this, and that. It becomes hard to follow. It's not clear. And in fact, in this case, if this element of this list element was undefined, your entire test is useless. Right? It's not asserting any of that stuff. So do not have ifs and the for loops in the tests themselves. It's fine to have them, of course, in components. Okay, I'll just leave it. It's fine to have it outside of tests because again, I treat components a little bit differently. But definitely do not put them in tests themselves. The other one is done for subscribers. If you do subscribe manually to things, put the done function here. This way, if the function, because again, if some in this case some service like something here, it creates an observable, and if this observable never emitted anything, your test kind of completed. Your expect will never actually assert anything, right? So done helps understand that it's done. So that's one. And in fact, if you prefer not the done but some other way, I mentioned the jest autospies library before. The same author has a very similar library that exposes subscribe to spy, so you can use that instead as well. But if you're just subscribing within your test, make sure you have done. All right. The other one is animations. If you have animations and other timings, do use the Angular animations, for example. Do use the no-op animations module. It will disable all the animations and make sure that things go faster as well. All right. And another one, like this is a frequent one. We love generators. We use generators. When you generate a component, it creates you a test with this. This is just an example. Do not keep it. Once you start writing the unit test in the file, should create component to be true, to just delete that. You have to test. Don't keep the useless test. Yeah, test nothing. Yeah. So just quick overview. Again, we understand why we need testing, why we test, what are good characteristics of the test, testing pyramid, right? The different type of tests, ciphers, simple injectable functions that explicitly return state to the unit tests. We walked over how to test services, no test bed needed. We went over how to test components, inputs, outputs together, right? Template and component class as a unit. We walked over some of the best practices as well after that. So thank you for listening to this presentation. I hope you learned something. I hope you inspired a little bit more. I hope you have now the itch to write the tests in a slightly better way that would actually, help you in the future. Thank you so much. All right. And we can do some of the testing, some of the questions now.
Thank you, Alex, for that session. I'll be taking over from Wayne. Yes, let's begin with the questions. So, we'll start with Drew.
Yeah, raise your hand if you want to have a question. Yeah.
Yes.
Go ahead,
Hello. Thank you for the session. I have so many questions. Some are simple, some are more of opinions, and I think some opinions we differ, and I'd like to understand your reasoning behind them. So
Definitely.
I'll start with the whole idea of mock. Now
Uh-huh.
you mentioned mocks a lot. So personally, while I understand the need for mocks, I'm not a believer in mocks because there's always a trade-off. The moment you mock, you're trading off testing the actual thing for the practicality of it. So it makes sense to mock things like network request animations, and then say you have like a checkout somewhere, you don't want to actually make the credit card payment. But then if you how do you limit the mocks? Because mocks would generate false positives, right? If you have a service A that depends on a service B and you mock service B, if the implementation of service B changes and your mock still lives, right, or someone doesn't go and update the mock, then essentially what you're testing in A with the mock for B is a false positive. And while that test might pass, it might not be a representation of how those two things are related. Um, and
Exactly. That's
specifically, I'm
why.
talking.
That's
Yeah,
why. That's a
and
very good question.
yeah, and I'm talking about like the idea around services. So how do you know or choose? Here I'm using the actual code, and here I am mocking, because again, way too many mocks could very easily result to false positives.
That's great. Yeah, that's a very good question. And in fact, that's exactly why I have different levels of testing. If I'm testing service A as a unit, I should only test its behavior. If I'm testing service B as a unit, I'll be testing its behaviors. Obviously, if the behavior of B changed and now you kind of assume that this is a behavior for A, that could be a problem. I agree. That's why we have an integration test level where A, B, C, D, and all the components, for example, are all working in tandem and we just mock the API calls, right? That level of test will catch the integration. That's why it's called integration. Integration between some of those services, actually integration of your app as a whole with the backends, right? That's where you would catch that change in the behavior. Now, but from the unit perspective, should I care how B is implemented when I implementing service A? I don't think so. We have sort of the expected contract. Again, the methods themselves and the properties things are exposing. Uh, if it does something, your service A would behave a certain way. So that's a brief one, I guess. The whole multiple services things, I can go very deep into this and talk about benefits of overall state management and things like that. But I'm not going to go to the state management territory, service spaghetti soup, whatever you call it, and all of those things. because again, I have many opinions in that area, especially when services have a bunch of services injected, then they have another bunch of services injected, and then you can go many layers deep. That's the whole advantages of state management. And remember, I was talking about the design as well. If you have services that have many services and same kind of picture repeats many levels down, it kind of starts highlighting that the design could be a touch improved. But again, that's all the details. From the high level perspective, we test things as units at the unit test level. And we have then integration test that kind of encapsulates a lot of this. Now, something that Lars is also proposing is like proposing sometimes you do need to have a feature level test. It's basically like a unit test, but as a feature, having all those services and components together. It's almost like integration, but on a component level. If your feature is large enough, it's critical enough, and there's multiple things happening, you could benefit of that level. It's almost like the intermediary level before you go full integration or end-to-end, some people call, with your ciphers where other services are mocked, right? So sometimes you do benefit from that layer as well. But unit test, again, I feel it's a very important part, describes how your test works, validates the behavior of that specific unit through its public APIs.
Okay, then my second question would be, I see you're using Angular testing library. So I subscribe to like Kenzie Dodd's Bible of testing.
Yeah.
And part of your test, you're like typing, and then I think you are checking a spy. And for UI components, my belief, at least when it comes to testing, is that you should, for the most part, test what the user expects to see. That gives you a lot of confidence that the app actually works as expected. So then why is checking for a spy, specifically when you're looking at testing the UI?
Yeah.
You have one of those tests and you say that's a good test. Like, why not check for the actual behavior of, say, what happens when you type on that search, or what happens when you...
Yes, and you do. When you type things in, you can validate that whatever you type is actually typed in. Although this is, I think it's a little bit poor testing, because when you type something in and say click or whatever and press enter, or sometimes on update, you do expect the component to either output something through your output, or call a method, the service with that output, right? So that's why you would put a spy either on the output itself, that, hey, that output was actually emitted now out of sight of the component. Like, component did its job from the component public API perspective. The behavior within component is complete. You type something through the template, the component outputted something, right? So it's complete. Or, if it's a service call or whatever else, that's validated, that, hey, the service is called. You don't care how service is implemented, what exactly service does after that. From the components unit test perspective, it's complete. But if you just type the text and validate that the text that you just typed in actually is there, that's again, if your input is a custom common component, for example, that's where you would validate that.
If say we were testing a login form, right? My test cases would go something like, if the email is wrong, then I expect an error message to be displayed. If no password is provided, or the password is too short, then I expect an error message to be displayed. If the user was to enter a correct email, the right length of the password, and they click the login button, I don't know if it's important for me to test that the login service has been called, or if it's important for me to test that we move from one page to another. Because from a user perspective, what they would see is, you click the login button, maybe the loading state is called, and then once the loading state is complete, you're transitioned to a different page. So
exactly, and this is where that's what you would validate from the integration perspective. So when you test login perspective from the end-to-end scenario, you would validate that, hey, you enter something through, again, you still do it through the DOM. You enter something, you click login, you intercept the login API call, you validate that it's actually sending you the right username and password that you correctly identified. Then you mock the response saying, yeah, this user is good. That passes, and then you check that you're end up being another page, whatever page you were navigating from. That's the integration test level. From the unit test perspective, from the component itself, all you care about when you enter the right things. Again, if you enter something that doesn't pass the validation, yes, you would validate the same thing. You'll do the screen, find by ID, whatever, and you say that this is the error message is present. Same thing for the wrong password format or something like that. But when you do the right things and you click OK, that should actually trigger some service, some method on some service, right? They'll do some service call. That would be your spy, and that's what you validate as a behavior of this component, that it did the right thing.
But isn't that checking for internal details though?
I'm sorry?
Like, because the thing I'm confused, and I think you might have noticed, I lean more towards integration than unit test. But even for unit test, the bit that confuses me is when you start spying on things, then very easily, and especially for the UI testing perspective, then very easily you're starting to check for internal details. Like, where's the line? Because
the line is, I do not interact, and I strongly suggest not to be interacting with the component instance itself. So okay. when I have my test bed or render function in the Angular testing library, I don't even export it outside of my setup function, because I know the second I start doing component.property equals something, that means I'm getting into the component internal implementation, and I don't want to do that. If I call, remember they had an example here of calling the method on the component, that's problematic right away. Where is it? Somewhere. Yeah. Like this component, this one, I'm interacting with the component instance. I'm not using UI. This is using UI, and this is the output of this component that was validated.
Okay. And then final question, because I know other guys also have questions. Sorry. Can you talk more about the harness exactly, and what its benefit is? Because if you go back to the example you had for when you first introduced Angular testing library before you introduced harness, I wonder, won't you get the same behavior by just getting the search box or the search input by role and then returning it in the setup?
Yes.
Opposed to, like, I'm trying to understand exactly.
Yeah. So this way, this way we're kind of relying that the search implementation inside has an input with a role input. We don't know, because again, our components it could be search component, it could be other things here as well, right? This is something that uses search component. Say this is my, I don't know, my home page that has the search component in. But when I interact with the search component, my page should do something about this, for example, right? Because I'm not testing, for example, search component here. And this way now I'm relying that search component has implementation of this input. While it might be true, and then sometimes, it might be true for the moment, if tomorrow there's two inputs, all my tests break for whatever reason. Now I need to abstract this from just, instead of finding the input and entering manually, I'll use the harness and say, hey, send those keys into this, or even better, search harness search. That would be even better name for this harness. Search and paste this thing in, right? And paste what I want to in, and then the search component would do something, and probably would produce the output, or in this way, so I just validated the value again, because it's the unit test of this harness itself. This one just validated the value. Again, how we read the value, where the value is typed in, we don't know and we don't care because we know that this is the value that it kind of keeps. That's basically the value of it. I highly recommend, let me just bring this one over. It's called component, component harness Angular. Component harnesses, and it's an Angular Material CDK component harness. It goes in details what it does, how to write it as a test author, and how to consume it as well. So for test authors, for component harness authors, which those are create component harnesses, how to create them, how to use them, and all that. I highly recommend. This is an amazing thing. Very useful, especially if you have large project, especially if you use some of the common components. Those would definitely benefit from test harnesses. In fact, Angular Material, I think, has a test harness for every Angular Material component already. Okay.
I'll stop there and read more on it. Thank you.
Yeah, definitely. I'm not even getting into the ciphers now because ciphers is a whole other beast. Good. Love the questions. Lots of good questions, Drew. Thank you for that. Anybody else has any questions?
If you have a question or comment, please feel free to unmute yourself and just speak up.
Hi, Alex.
Hey, Drew.
Can we use the same logic for ionic capacitor project?
Yeah, 100%. You should be able to use it. I mean, underneath it's still Angular. I'm not sure if ionic components themselves provide test harnesses. I don't quite remember. You probably saw me somewhere. I was using an ionic example somewhere. Yeah, logic. Here, there's ion item. I don't remember if ionic itself provides test harnesses. You might want to implement your own, but the same logic could be used for ionic, for ciphers tests. With this, you'll have a different setup. But against, for example, ciphers themselves, you can use for pretty much anywhere. And I mean, in React is using ciphers. They call them differently. It's just a way to reliably set up your test environment and more readable versus see, it's so much easier to follow where it was created, how it's used, when it's returned, and how it gets into the test versus just declaring it here, randomly assigning it somewhere else, and then it all of a sudden appears in the test. In fact, that's a good question. In fact, I see a lot of components that are written kind of the same way as this test, where you have a property that's declared, then in some method, some callback, I don't know, on it, some things is assigned, then some other methods is called, and that property is reused. That's also the anti-pattern. Again, I'm not going to go in that direction, but we're trying to break those anti-patterns, and we're trying to be where things are, very explicitly and easily traceable, and actually returning things and reusing things.
Thanks.
All right. Good question.
Any other question or comments?
Yeah. And as you might have noticed, it's not a special library. It's not. It's just a pattern how to organize your tests. Awesome. Good questions.
Can I throw one more in?
Yeah. Feel free.
So the thing, and this is, I've struggled, especially when testing things that are async, when timeouts are involved. And I know Jest has this fake timer and fake async, but I find that tests that are in that nature are not deterministic. It's almost, they become very flaky. Sometimes they pass, sometimes they don't.
Yeah.
How do you make them robust? How do you, especially asynchronous and things to do with timers, how do you ensure that
Yeah. Where is it?
it always passes?
Here. So if I'm dealing with time, I mean some time sensitive things are happening, I remove the time out of the equation altogether with fake async. Right. So fake async, it also works with jest. It calls some of the jest things there. You can remove the time out of equation, so it's not if you test itself, not the plus the setup jest runner does. If your test itself takes more than a few tens of milliseconds, then your test is doing something that it shouldn't be doing. The unit tests should be really, 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 really fast. That's why they're the bottom layer. There's many of them. They're really unique testing things. They're removing any abstraction. They should be really, really fast. If you have a test that sometimes times out, that means that test is doing something. Maybe it's pulling some other service that does some call, or all those things that should be isolated. And if your component itself does time sensitive things, use a fake async. You can flush it. You can flush micro tasks as well if you're doing something like the promises resolves and things like that. Or you can take things to advance it to certain points. Look into fake async. So most likely there's something going on with the test. Also, frequently, it could fail again because your tests are sharing something between each other. And again, this is where the ciphers will really isolate things for your test specifically. It was just recently I was called, some of my teammates were asking, hey, I have my test that sometimes fails, sometimes, but I'll passes locally, and then I push it into the CI, and Circle CI fails it. Why is it happening? Well, Circle CI environment is slightly different, so it was actually timing out there, but it was fine on the local machine. It just immediately we started looking at the test itself, and we found there was some behavior subject that was set outside of the setup function. It was just somewhere up, and it was shared between tests, and that was failing it. That's exactly, when you have things outside, they can affect the test. When you push everything inside the setup function, you're currently guaranteeing it that it's one per test, right? Each test will instantiate it. It's almost like before each, but a better before each, more guaranteed before each. And the other one as well, make sure something I talked as well, the global things. You don't have global things shared because sometimes you set it someplace. Where is this global thing? Hey, global. Yeah, this type of stuff. When you new something, or even if you're not new, you're using some third-party stuff that just appears in window object, right? In the global scope, you are setting it some tests and not setting another. Don't do this. Make sure you use like injection tokens, and then you mock it in your test. All right. Another great question, Drew. I see you came prepared. It's awesome.
I write that, unfortunately.
So who changed their mind and now loves tests?
Okay. So is there any other question? Okay, cool. Any comments? Okay. Sorry?
Can you share the resources, especially the ones to Cypher and Harness?
Yes, I'll share the resources. In fact, Joy, I think Anglo team will release this video to YouTube. Probably would tweet about this as well. I'll reply with that and share the resources in there as well. So do make sure to follow me on Twitter as well. I'll share that as well. It's at Alex Akrushko right there. Very easy to find. And I'll share some of the resources probably tomorrow once I have this out.
Okay. So thank you, Alex, for the enlightening presentation. Honestly, I've never written tests before, so this was quite new to me. Yeah, but it's
Yeah.
something I'll start maybe, hopefully, in a month or tomorrow even. I'll see. But thank you so much. Yeah, it's been an amazing session. I've learned a lot. And Wayne, are you here?
Yeah, I'm here. I'm here.
Okay. Do you have a comment or a question?
Yeah, unit
No,
testing is something that is strictly required in both organizations that I mean, in all organizations that I worked with. And I know it's not always the case. Luckily, in current situation, I was able to enforce this as well. We have unit test is not an option, regardless of how late your project is or whatever. It has to come together with the same PR. So PR won't be accepted if it doesn't come with unit test. In fact, if it's a fix, I would also recommend first writing the unit test that will be broken for that fix. And then you fix thing, and then you see the test starts to passing. That gives you, remember the confidence part? It will also give you the confidence that you at least fixed something, right? And now it's passing as well. So yeah, unit tests are basically the requirement as any of the PRs in the environments that I work in. Yeah.
Okay.
Thanks.
Challenge accepted, I guess. Wayne?
no, I'm all good. Just say thank you to Alex. It was a super interactive session. So thank you. Thank you very much.
Yeah, thanks for having me.
Okay. Lastly, I'd like to tell you guys to kindly RSVP for our event on Saturday, meet and greet. We want you guys to have the first priority. So make sure you, after this call, if you haven't RSVP